Have you ever wondered what makes your car's engine run smoothly? One crucial component in maintaining that engine performance is the map sensor. But what exactly is it, and why is it so important? In this video, we're going to dive into the world of the map sensor, exploring its key role in your car's engine performance. Stick around to learn how this small but mighty part keeps your vehicle running at its best. Before we get started, don't forget to hit that like button, subscribe, and turn on the notification bell so you never miss out on more car maintenance tips. Now let's jump right in. What is a map sensor? The map, manifold absolute pressure, sensor is an essential component in modern vehicles, found in the intake manifold. It measures the air pressure within the intake manifold of the engine and sends this data to the engine control unit, ECU. This data is crucial for the ECU to determine how much fuel is needed for efficient combustion. The map sensor plays a significant role in the vehicle's performance by providing real-time pressure information, allowing the engine to adjust accordingly for better fuel efficiency, power output, and emissions control. Without a functioning map sensor, the engine's performance could be severely impacted, causing issues like poor fuel economy, rough idle, and potential engine damage. The map sensor is usually located near the intake manifold, where it can detect air pressure variations that occur when the throttle opens or closes. Number 1. Improved fuel efficiency. One of the primary functions of the map sensor is to provide critical data to the engine's ECU about the pressure within the intake manifold. This helps the ECU adjust the fuel-to-air ratio to ensure optimal combustion, which directly impacts fuel efficiency. When the map sensor works properly, it ensures that the engine gets the right amount of fuel for the right conditions, avoiding excess fuel use or underperformance. The engine control unit can use the map sensor's readings to adjust the timing and quantity of fuel being injected, which ultimately leads to a smoother and more efficient running engine. In turn, this efficiency translates into better mileage, which can significantly reduce overall fuel consumption and operating costs, especially for drivers who do a lot of commuting or long-distance driving. Additionally, the consistent fuel efficiency helps to preserve the engine's components, extending its lifespan and reducing the need for frequent repairs. Number 2. Enhanced engine performance. A properly functioning map sensor contributes to improved engine performance. It allows the engine control unit, ECU, to make real-time adjustments to engine parameters, including ignition timing and fuel injection timing. This ensures that the engine operates at peak performance, responding quickly to changes in driving conditions such as acceleration, deceleration, and load changes. For example, when the vehicle accelerates or encounters an incline, the increased air pressure within the manifold is detected by the map sensor. The ECU can then adjust the fuel mixture accordingly, providing the engine with the power it needs. This dynamic response ensures that the engine performs optimally, delivering power when required without hesitation or loss of performance. Without this responsiveness, the engine would struggle with fuel delivery and air mixture adjustments, leading to poor acceleration, sluggishness, and overall reduced driving experience. Number 3. Reduction in engine emissions. A map sensor plays a vital role in managing a vehicle's emissions, which is a key concern for modern cars designed to meet environmental standards. By monitoring the air pressure inside the intake manifold, the map sensor enables the engine control unit, ECU, to make precise adjustments to the air-fuel mixture. This helps ensure that the combustion process is as clean as possible, leading to reduced exhaust emissions. If the ECU receives inaccurate readings from a faulty map sensor, the air-fuel mixture could become too rich or too lean, leading to incomplete combustion and the production of harmful pollutants. With proper functioning, the map sensor helps optimize combustion, improving the engine's efficiency and minimizing harmful emissions, which benefits both the environment and the vehicle's compliance with emission standards. Number 4. Better throttle response. The map sensor is crucial in ensuring that the throttle response of a vehicle remains smooth and precise. The throttle is responsible for regulating the amount of air entering the engine, which in turn affects the amount of power generated. When the map sensor detects changes in pressure inside the intake manifold, the ECU adjusts the throttle position accordingly. This allows the vehicle to respond immediately to changes in driving demands, such as when the driver presses the accelerator. If the map sensor malfunctions or provides inaccurate data, it can cause sluggish or delayed throttle responses, which may result in jerky or unpredictable acceleration. The sensor's ability to monitor manifold pressure ensures a seamless throttle response, improving the overall driving experience, especially in situations like overtaking or quick acceleration. Number 5. Preventing engine knock. Engine knock, also known as predetonation, occurs when the air-fuel mixture ignites prematurely within the engine cylinders, causing a knocking or pinging sound. This can result in reduced engine performance, damage to engine components, and decreased fuel efficiency. The MAP sensor helps prevent engine knock by providing accurate manifold pressure data to the ECU, allowing it to adjust the ignition timing. When the pressure in the intake manifold is high, indicating a higher load or throttle position, the ECU can retune the ignition timing to prevent knocking. This adjustment helps avoid early combustion, ensuring that the engine operates smoothly and efficiently under various load conditions. If the MAP sensor were to fail, the ECU would be unable to make the necessary adjustments, potentially leading to engine knock and long-term damage to the engine. Number 6. Optimized idle control. The MAP sensor also contributes significantly to maintaining stable engine idle speeds. When the engine is idling, the ECU uses the pressure data from the MAP sensor to determine how much fuel to inject for optimal combustion. A proper air-fuel ratio at idle speeds ensures the engine runs smoothly without stalling or surging. A malfunctioning MAP sensor can lead to incorrect fuel delivery, causing erratic idling behavior such as rough idles, stalling, or inconsistent engine speed. This is especially noticeable when the vehicle is in gear and at a stop. By providing accurate manifold pressure data, the MAP sensor helps the ECU make real-time adjustments to fuel delivery and air intake, maintaining a steady idle that improves the driving experience and reduces wear on the engine. Number 7. Facilitates engine diagnostics. The MAP sensor aids in diagnosing engine problems by providing critical data to the onboard diagnostic system, OBD2. When there is an issue with the sensor or the engine's performance, the OBD2 system can use the data from the MAP sensor to identify trouble codes that may point to specific problems, such as faulty sensors, poor fuel mixture, or malfunctioning components. A malfunctioning MAP sensor can trigger an error code in the system, alerting the driver or technician to the issue. This makes the process of identifying and addressing engine problems quicker and more accurate. If the sensor is faulty, diagnostics will help pinpoint it as a source of the problem, enabling faster repairs and minimizing downtime for the vehicle. The MAP sensor's role in diagnostics ensures that engine issues are detected early before they escalate into more serious and costly problems. Number 8. Support for turbocharged and supercharged engines. Turbocharged and supercharged engines rely heavily on precise air pressure measurements to optimize performance. The MAP sensor is particularly important in these high-performance setups because it monitors changes in manifold pressure due to forced induction. When the turbocharger or supercharger increases air intake, the MAP sensor detects the higher pressure and signals the ECU to adjust the fuel delivery and ignition timing. This ensures that the engine operates smoothly, providing more power when needed without causing engine stress. In forced induction systems, improper air-fuel mixture adjustments can lead to severe engine damage or reduced performance. The MAP sensor ensures that turbocharged and supercharged engines receive the correct amount of fuel for the increased air pressure, allowing them to deliver optimal power and efficiency without compromising engine safety or reliability. Thanks for watching. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more car maintenance tips and tricks. Drive safe, and see you in the next video.